Hello and welcome, everybody. This is Mr. Hoke talking here. IA Unit 7B, Day 4. Our learning target is I can multiply polynomials. So today we're going to go over taking a monomial times a binomial times a binomial, and then finally a binomial times a trinomial. We're going to be talking about two different methods as well. We're going to talk about the box method and also distributive property as well. So let's get into it here. So here's our first. We're going to take 4x times the quantity of 3x plus 2. So a monomial times a binomial. So I'm going to go ahead and create this here. So when I set this up, I'm going to write 4x like so. And then 3x on the side, followed by 2. Then I'm going to create a box. Then what I'm going to do is I am going to multiply the two terms. So 4x times 3x is going to be 12x. Now remember, this is the first, so we have the same base. So our we're going to add the exponents. So this is going to be x squared. And then we're going to take 4x times 2 and get 8x. So this would be 12x squared plus 8x. So that's one way that you can go about doing it. And it's just nice because it provides you a visual so you can kind of see, and it makes it so it's not as complicated. And when we get into like a binomial times a binomial or a binomial times a trinomial, and you have a lot of different terms, I think the box method will be good for a nice visual. Now, when it comes to distributive, you're going to take the term that's on the outside of the parentheses here, go ahead and distribute the 4x to both of the terms that are inside here. So 4x times 3x is going to be 12x squared. And then 4x times 2 is going to be 8x. So either way, as you see we do some of these problems, you're going to get the exact same answers. It's just a matter of what method you choose in order to get that answer. So here's a binomial times a binomial. So let's go ahead, set it up in the box method here first. So our first term here, n, and then 2, then n here, and then 5. So what I'm doing is I'm looking at my two different, so I have different terms in here. What I mean by that is I have a linear term and it's constant, and a linear term and it's constant. Now you can see that since there's two terms in each, there's going to be 4 boxes. So the easiest way I can think about it is 2 times 2 represents 4 boxes. Now that doesn't always mean there's going to be 4 terms, and we'll get into that here. So n times n is going to be n squared. So again, where they meet, so it's where 2 and n meets, that's where you're going to multiply. So 2 times n is 2n. Right here, this area where they meet is where 5 and n meet, so that's 5n. And then this 5 and 2 meet here. 5 times 2 is 10. So you might be thinking, hey, there's 4 terms here. However, it's not going to be a polynomial. This is going to be a trinomial. And here's why. Now, when we take a look here, these are like terms. These are like linear terms here. So now you're going to combine likes or simplify. Okay. Both of these are positive. So after you go ahead, you're going to get n squared, 2n plus 5n. And we know that since they're both positive, we're going to add them. We'll show an example where we're going to have negatives here later. So 2 plus 5 is 7n. And then there's nothing, there's not another term that's constant, so it'll be plus 10. So that would be the box method. The distributive method, we would do this. I'm going to take my first term here. So I'm going to take n times n, which is n squared. Then I'm going to take n times 5, which is 5n. Then I'm going to take 2 times n, which is 2n. Then I'm going to take 2 times 5 and get 10. Now I need to look for constant, or not constant, I need to look for like terms. So I only have one quadratic term. I have 2 linear, so I can combine those and only have one constant. So n squared is going to stay the same. So is the 10. Now I'm going to combine these because these are both linear like terms. So 5n plus 2n is 7n. So again, it's total preference, as you can see, and as you're getting more used to the two different methods, hopefully you're finding one that fits or works best for your style. But we'll continue to do a few more where we go over both. All right, so this is n plus 5, that quantity squared. So why this is a little bit tricky is sometimes we just square the first and second term and we forget about the middle term. So it really helps us. So the box method is really nice because in this situation, because it helps us just write all of this out. So n squared, there's my first um, n plus 5. Then I'm going to have another n plus 5 here. Box this up. Again, n plus 5 and n plus 5. If you wanted to, you could also rewrite it just like this. Represents the same thing. You can see that this is going to be another 4 squares here. N times n is n squared. N times 5 is 5n. N times 5 is 5n. And 5 times 5 is 25. So again, what I'm going to do is I'm going to look for like terms. So where they are similar or like. So those are two linear terms, both positive. So I'm going to add, this is what I'm going to get. N squared, 5n plus 5n is 10n. And this is plus 25. Now I could also just go ahead and distribute. So for me, if I'm ever see a squared, I just like to kind of like cancel it out and write it out because I'm very visual. So this allows me to do this. So first I'm going to take n times n, get n squared. Now I'm going to take this n times the 5 here and get 5n. Okay, so all I'm doing is I'm taking the first term listed here and I'm multiplying it by all the other terms found in the second quantity. Then I'm going to take the second term listed here and I'm going to multiply it by all the terms in the second quantity as well. So 5 times n is 5n. And 5 times 5 is 25. So then you're going to combine terms that are like. Here's my like terms. I'm going to get n squared plus 10n is 25. So again, hopefully you're kind of seeing and starting to develop a method that works best for you. That's the goal here, is that we find one that we really like, but it's good to be good at both as well. So at this moment, if you want to pause the video to go ahead and try these on your own, feel free. So I'm going to let you pause if you wish, but I'm going to continue here. So the first thing I'm going to do is I'm going to get rid of the squared and write it exactly as I see it, 4x plus 2y. I'm going to set this up in box method, 4x, 2y. Both are positive here, 4x, 2y. So now I'm going to go ahead and multiply. So the product of 4x and 4x will go here. So 4 times 4, 16. X times x is x squared. Because remember, first power, when you have the same base, you add them. So here I'm going to take 4x times 2y. So 4 times 2 is 8. And then x and y, you can't combine because they're different bases. So you're just going to write them exactly as you see them, x, y. Now when we get here, 4 times 2, 8. And I can't really multiply the x and the y because they're not the same base. I can't, like in this case here, you can see that I added the bases powers to get squared. However, these are different bases, so that would not occur. So I'm just going to get 8xy here again. And then 2y times 2y, so 2 times 2, 4. Now we do have the same base of y and y, so we're going to add their exponents and get y squared. So now what we're going to do is we are going to combine likes. 8xy, 8xy. Again, the coefficients don't have to match. This is just a coincidence. However, the variables and their powers do. So my leading coefficient is 16, and that leading term is 16x squared. 8xy plus 8xy. Again, you would just add the coefficients. You're going to get 16xy. And then there's nothing to combine with, so this you'll just write as you see it. 4y squared. All right, so now if we want to go ahead and try the distributive method, first term here, 4x times 4x is going to be 16x squared. 4x times 2y is going to be 8xy. Again, same concept. You don't have similar bases, so you can't actually add powers to them. You just got to make sure that both bases are represented. Then I'm going to take the second term times this first one. 2y times 4x is again going to be 8xy. Again, 2y times 2y is going to be 4y squared. I can combine. I'm going to get 16 squared, 16x squared, I should say, plus 16xy plus 4y squared. Now, sometimes they can look a little bit more involved, like in this case. This is still a monomial, okay, times a binomial. Okay, even though they got a little bit more going on with them, a few more terms, a few more bases, not terms, but a few more bases, make sure that the process remains the same. So in the box method, I'm going to write what I see here. You might be saying, hey, Hoke, why are these together when the other ones weren't? Well, you can see that these are this is one term. Before, like we were doing ones that like n plus 2, these are two terms. N plus 2, so two terms. This is a binomial. This is still a monomial, okay? So be aware of that. I'm going to erase that to avoid confusion, but I just wanted to just show you that I'm not parting this out because this is just one large term. So then I'm going to multiply it by this. Box it. Okay, first multiply the coefficients. 3 times negative 4 is a negative 12. Base is m. Base is m. So when they have the same base, you're going to add the 3 plus the 2 and get m to the 5th. And n to the 1st times n to the 3rd. So when that occurs, you add them. So it's going to be 1 plus 3, which is 4. So negative 12, m to the 5th, n to the 4th. Here, let's multiply the coefficients first. Negative 4 times 5 is going to be negative 20. M squared times m to the 1st. Remember, same base, you're going to add. So 1 plus 3 is, or 1 plus 2 is my power of 3. It's an m, by the way. And then n to the 4th, n to the 1st is going to be n to the 5th. So then you would just write it out. None of these are like terms, even though they're both m and n. They have different powers, so you cannot combine them. So you're going to get negative 12 m to the 5th, n to the 4th, minus 20 m cubed n to the 5th. Okay, let's do the distributive method as well. So here, you'll get negative 12 m squared, m to the 3rd, so it'd be m to the 5th, n to the 1st times n to the 3rd is n to the 4th. Now let's go ahead and multiply here. Negative 20 m squared, m to the 1st, 2 plus 1 is 3. Then 1 plus 4 is 5. So that should match exactly what we got here. It does. All right, let's get into our last one of the video. So this is a binomial times a trinomial. This has 2 terms. This has 3. So when you make the box, you should have 6 boxes here. So let's go ahead and do that quick. So we have n and then 3. You don't put them together because they're not one term. These are separate terms here. Then we're going to have n squared. We have n. Then we have negative 4. So you can see that I have my 6 boxes here. 2 times 3. So n squared times n. So really remember, same basis. 2 plus 1 is 3. N times n, same basis. So you're going to take 1 plus 1 to get n squared. N times negative 4 is negative 4n. 3 times n squared. Remember, the coefficient of n squared is 1, so it's really 3 times 1. So it turns into 3n squared. 3 times n is 3n. And then 3 times negative 4 is negative 12. So we're going to combine likes. We're going to see that there's a few likes that we can combine. N cubed is the only cubic term. There's no other one, so it's going to be written alone as n cubed. Next, we're going to go to the squared or the quadratic ones. So there's 1, 2 that match. They're both positive, so 3n squared plus n squared is going to be 4n squared. Next, you're going to look for your linear term, 3n and negative 4n. So when you add those together, 3n plus negative 4n, you're going to get negative n. And then lastly, we have our constant term, which is just negative 12. So we're going to get this polynomial. And it's always a good idea to just make sure that you don't have any, like in your final answer, that you don't have any terms that are both the same. Like just check for constant terms that might show up, or maybe linear terms. So making sure that there's no repeat. So here I have cubic, quadratic, linear, and then constant. So let's go ahead and try the distributive property here as well. N times n is n cubed. N times n is n squared. N times negative 4 is negative 4n. 3 times 3 times n squared is 3n squared. 3 times n, 3n. Then 3 times negative 4 is negative 12. So then what we're going to do is we're going to look for like terms. So these are like, and so are these. Only have 1 cubic and 1 constant, so those cannot be combined. So in my final answer here, I'm going to get n cubed. I'm going to combine these. 1 plus 3 is going to be 4n squared. Negative 4n plus 3n is going to be negative n. And then my constant term is negative 12. And as you can see, it should match here as well. All right, thanks so much for paying attention to this video, and please be sure to review it. If you have any questions for me, please send me a question. All right, until next time, have a great rest of your day, and I will see you later.